Okay, this first page, no, we're not doing this all again, okay? As you remember, we did the races, and this is what we got from our table, okay? As you can see, we just keep steadily increasing by 35. That's a line. Here it goes up, comes back down. That's a parabola. Okay, now let's put this into action, okay? A go-kart has, with algebra a go-kart track has 380 racers and charges $35 to race. For every $1 in decrease in price, 20 more racers will come. How many times should the store decrease the price by $1 to maximize its revenue? What will this maximum revenue be? Now we're going to put some algebra into action to solve this a little more efficiently. Maximum revenue is a total, and don't just put revenue, it's maximum revenue. Okay, so what I'm not going to do, I'm not going to mess around here. And the reason why is because it ain't a line. Lines don't have maximums. Parabolas do, okay? And I'm trying to find the maximum point, and there's an x and a y at that point, so x comma y. The formula to find the x from yesterday in standard form is opposite of b divided by 2a. And story problems usually end up in standard form, so we're going to go with that. Opposite of b divided by 2 times a. Okay, now what we need to do is generate an equation from the problem. Now with parabolas equations, you kind of just have to know a base formula. Okay, so I'm going to put base formula. Now we're talking revenue here, so my base formula is revenue equals the money times the number of items. And if you look back to that first page, what I was doing again to find my revenue is I was taking the money times the number of items. The money per item times the price per item. Okay, so here's what I'm going to do. The revenue is going to be our y. And then what I'm going to do is make a parentheses for the money and a parentheses for the items, because it's more complicated than just taking a money amount times items. So I'm going to make a parentheses for my money amount and parentheses for my items. Now, what am I charging here? I'm charging $35, but I'm decreasing the price by $1, and I'm doing that repeatedly over and over and over. So it's 35 minus 1x. Okay. Now the number of items, we have 380 racers to start with. And then what's happening there? Well, when I'm minusing 1 from here, I'm adding 20 to this, and it'd be 20x. That's simple. Now, I don't have an a and a b because right now it's in factored form. What I need to do is simply multiply using the FOIL method. Okay? So first, I've got 35 times 380, and I've got 35 times 20x. That takes care of the 35. Now I got negative 1x times 380, and then negative 1x times 20x. Okay, now this is 13,300. That's the product there. The product here is 700x. The product here is negative 380x, and the product here is not just negative 20x. If both factors have an x, the x goes to the second power. Okay, now I've got negative 20x to the second. That's what I put first. That's my a. The x is second term. A is negative 20. Now for x's, I add those. Those are like terms. So I take 700 plus negative 380, and that's positive 320x. And then I've got the 13,000. That's your b. And then I've got 13,300, but I'm not really going to have to use that in this short formula. Okay, so my opposite, here's my b, here's my a. My opposite of b is negative 320, since it was positive 320. And now what I do is I take my a times 2. Negative 20 times 2, that's negative 40. Negative 320 divided by negative 40 is 8. But that's not your revenue, okay? The 8 is how many times you took the price down by $1, okay? That is not your maximum revenue. To find the max revenue, you need to replace the X's with 8s, okay? 8. So I go on my calculator, because it's just easier. Unless you want to do, please excuse my dear Aunt Sally, the calculator is going to be the best. So I've got negative 20, parentheses 8, because it's x to the second, and then the second power is here, plus 320, parentheses 8, plus 13,300, and y equals 14,580. And that's my maximum revenue, okay? So 14,580 is my maximum revenue, as it was when I did that table. Now the next one. A video store sells about 150 DVDs at a price of $20. The owner estimates that for each $1 decrease in price, 25 more DVDs will be sold each week. How many price changes should occur for the store to maximize revenue, and what should the maximum revenue be? So basically the bottom line is I'm finding the maximum revenue. So again, with maximums, I don't do that because I know it's not a line, okay? This really only serves me well if I know it's a linear. So maximum's obviously a parabola. So I need to find the x point, x and y point, both those I need to find, okay? And the way to find this is oh yeah, by the way, on the last problem, yeah, never mind, I did it. Opposite of b divided by 2 times a. Okay, now I need to know my base formula for revenue. It's simply the money charged multiplied by the number of items. So that becomes y. And these two I replace with parentheses. Okay. So when I'm looking for money, it starts at $20, but then we decrease it by $1. So that's going to be 20 minus 1, but it needs an x because it happens repeatedly. Now the items, we got 150 and 25 more, okay? So if we're minusing here, we'd be adding here, so 25x. Now I got to put it in standard form because right now it's in factored form. So I got 20 multiplied by 150. I've got 20 multiplied by 25x. I've got negative 1x multiplied by 150. And I've got negative 1x multiplied by 25x. Okay, so this is 3,000. 30. Yeah, it's 30,000, sorry. Equals 500x equals negative 150x, and that's negative 25x to the second power, okay? So negative 25x to the second power is my A. I combine these, those are like terms. That's going to be 350x, that's my B, plus our, just a second, I might be just dumb here today. Oh yeah, it's not 30,000, it's 3,000, okay, 3,000, okay. Alright, so the opposite of the B, so it's going to be negative 350, okay. Then I take my A and times it by 2, that's going to be negative 50. So divide and I get 7. Once again, that ain't your max revenue. The max revenue is the Y. But I can easily find that if I plug 7s in for those X's, because I know X is 7. So negative 25 and then 7 to the second plus 350 parentheses 7 plus 3,000. 4,225. So what that solution means is I take the price down by $1 7 times, so I end up charging $13, and the max revenue ends up being 4,225. Okay, next. An online music store sells 4,000 songs in a set time when it charges $1 per song. For each 5-cent increase in price, 80 fewer songs are sold during this time. How many price changes occur before the store reaches its maximum revenue? What will this maximum revenue be? So again, I'm finding the maximum revenue. So again, forget that's irrelevant. It's just really making a path and generating an equation from the path. Okay, so I'm trying to find my x at the max. It's the opposite of b divided by 2 times a. Now I need to get a standard form parabolic equation that has a b and that has an a. So the revenue equals the money times the items, I guess, songs in this case. I like to just stick with money times items, and that's y. So each of these factors are going to have a parentheses. Okay, so my money amount, I've got $1 and then 5 cents. So we start them at $1, but this time we're doing a 5-cent increase in price. So plus 0.05x. And then the items, I've got the 4,000 and the 80. So I start with 4,000 songs. Now if I raise the price, we're going to take away from here. I mean, that's how business works. Raise the price means you're not going to have more people buy because it's more expensive. You're going to have less. Okay, so we got 1 times 4,000. We've got 1 times negative 80x. We've got 0.05x times 4,000. And we've got 0.05x times negative 80x. Okay, so that's 4,000 plus negative 80x. 0.05 times 4,000 is 200x. And that times that is going to be negative 4x to the second power. Wait a second. I shouldn't even be writing that. I should just be putting them right here. So, again, that's 4,000, negative 80x, 200x. That's negative 4x to the second. So, negative 4x to the second, that's my A. Collect like terms there. Negative 80 plus 200 is 120x. That's my B. Plus 4,000. Okay, so take that up here. Opposite of B would be negative 120. You take your A times 2 is negative 8, and that's 15. Now, to find your actual revenue, that's what Y is. You need to actually plug in 15 for each of those X's. So negative 4, 15 to the second, plus 120, and then 15, plus 4,000, okay? 4,900. So if I up the price by 5 cents 15 times, I get 4,900. That's why you don't want to just make a table, because that's going to take forever on this problem, okay? I mean, it was long enough on that first problem, but if you have to go 15 price changes before you finally see it start to go down, that's going to take a long time. Okay, now the next problems are different. They're even easier than the revenue. It says a missile is launched from a 100-foot platform with a velocity of 725 feet per second. What's the maximum height of the missile? The missile travels in a parabolic path. Max height, but I want you to put max feet because the height's in feet. So we're going to forget that. Don't need that. And again, we're finding the max. So the way to find that, opposite of B over 2 times A. And then plug it in, and that'll find Y for us. Okay, now I don't need as much workspace here, and the reason why is because I can get my base formula right away, and it's going to be in standard form right away. It won't be in factored form. Here's what the revenue, here's what a velocity, it's called gravity, okay? Here's what the gravity equation is. You take negative 16 and then time to the second power plus the velocity multiplied by your time, just your time, plus the start height equals end height. Okay. Here's how I do this. Here's an easy way to remember. Negative 16. The reason you have negative 16 because the force of gravity on Earth is represented by negative 16. Time is x, so x to the second power. The velocity is the feet per second, in this instance 725, and that's time, so that has an x. Plus the initial height, start height was 100 feet above the ground, and the end height I don't know, that would be represented by y. So it's already in standard form. I just need an A and I need a B. So the opposite of B is negative 725. And the product of 2 and negative 16 is always negative 32. So negative 725 divided by negative 32 is going to be 22.7. That's not your max height. That's a time it took to reach the max height. Now to find the max height, we're going to plug in 22.7. It's actually less work on these than on the revenue ones because I don't have to do the FOIL method because it's already in standard form. Okay, and that's going to be 8,313. I like to round to the nearest hundredth. Okay, so 8,313, and that's our maximum height. Okay, next one, a football's kicked off the ground, velocity of 100 feet per second. What's the football's max height? So again, height isn't really a unit, so put maximum feet. So I've got feet and seconds. X is, oh yeah, I'm not even doing that, okay, because I know it's a max. Opposite of B divided by 2 times A. Now your base formula for the gravity is very easy. Again, negative 16 time to the second, x a second. And then my velocity, a lot of people get the velocity wrong, 100x. And there's really no starting height, so I skip over that and I just put equals y, okay? So opposite of B is going to be negative 100. 2 times the A is negative 32. Then I divide negative 100 by negative 32, and that's going to be 3 point, we're just going to say 3, okay? That's the time it takes to get to the max height. Now to find the max height itself, you need to plug and chug the 3 into that equation, and that's going to tell us what y equals. Okay, so I got 156, so 156, and that's our max height. Okay, now that's really all I have to say today. I hope it's been informative, and we're not going to do the last example. And your assignment is numbers 1, 2, and 3. This one's a revenue, and these two are going to be the gravity for the base formula. These are gravity. And that one right there is revenue.